Okay, because I didn't have a setup template, it loads my fixture model, it loads my stock model. Go ahead and make that invisible, and it loads my design model. Visibility, both views. Okay, and I'll go ahead and do both views. I'll make it visible and visibility, both views. Okay, cool. So I need a machine and I need a control. So for the machine, go click on my machine model. We go to my C drive, program files, CGTech 9.3, library, and we're going to grab a Haas UMC 750. I'm going to go to my control file. Haas UMC. We'll open that up. And I'm going to do a reset. And what I'm doing here, this is going to be like a stock view. So I want to change the view type. Let's go to the view menu. Let's give me a 2 view. This is taking a minute.
Would this be one of those operations that would run faster with that simplified solids?
Potentially, but what I really think this is that I'm running this demo license, and I think there's some stuff that's kind of restricted on the normally this is literally you click it and it just switches.
Right.
So really, I think this is something that I'm gonna have to get resolved with CG Tech to find out are the licenses we're using restricted, or is this just you know, something that's going on with my license file? Is it something with the actual installation of 9.3? Is it a bug in the software? Like, what's going on? Because normally, if I change to a 2 view layout, it's just like instant. Now, one of the things that it did do for us, or it should have done for us, I should say, is it did output our files. So I've got my tools, I've got my all this stuff. See if there's anything in the log file. And nothing in the log file. So let's kill it. And what I'll do is go MCAMV run Vericut. Maybe it wasn't done killing it. Make sure to save it. Oh, it's just hiding back here. Okay, so I'm going to do run Vericut. First, let's take this extra setup. See if we can delete it. Okay, let me do that. I'm going to save my VC project file. Okay, let me do that. If I go to view, okay, let me do that. Let me see if it'll let me change my view type. Okay, so let me add a machine view. So there's my stock workpiece view. Here's my machine view. So I was able to do that. Now I'm going to add a control. And you know what may be a problem is program files CG Tech library. Oh, I've got full control. That's good. Okay, so now what I'm going to do, let's find our UMC 750. Haas UMC 750. Oh, even got power on off buttons. Look at that. So I'm just going to grab everything that says Haas UMC 750. I'm going to copy it. I'm going to paste it. Okay. In 3 files. Do we have UMC controller, CNC control, CNC sub? Hopefully we got everything. So now, if I go to my Vericut file, I've got my control. So I'm going to open the control. I go to the machine. Grab my UMC 750 machine. Shows it's busy. Stock design view. Where's my machine view?
And you see, there's a configure machine menu that I think popped up in the lower left. What is?
This guy down here.
Yeah.
Yeah, so it's because I've got the machine up here selected, and
Okay.
don't know if it's got anything as far as making it visible or not. CNC machine. I don't care about the machine origin right now. The one thing I don't have now is like my program 0. So what I really need is attach coordinate system to stock. Okay, program 0, attach coordinate system to stock. Offsets. Tools. Normally there's an option for coordinate systems that says basically go from spindle to stock, which is what we need. There's my program 0. Yes. There's my top. Okay. Site. Nope. Nope. So it should be visible. All my components are there. The visibility. See, this is a machine view, so it should be showing my machine. No animation. Machine offsets. Don't need to worry about that right now. Let's see. Don't need to translate anything. Spindle to stock. I needed a G-code offset. G-code offsets, work offset 1, may have to be work offset 54. And basically spindle to stock. So from component origin spindle to component origin stock. That's my G-code offset. So there we go. That shows that that's now the active actual driven point. It's weird that it's not letting me see my machine. So let me go in here. Project tree, fit selected. Oh. Don't want machine import. Default work offset table. Entry not found. Let's try work offset 1. Oh. 54. Spindle to stock. That's better. So we can see it's got all kinds of issues,
Right.
right? So we've got all kinds of gouges that are basically being caused by the holder. So what do we need to do here? Now, the question is it being caused by the actual holder hitting, or is it being caused because it sees that the flute length is not long enough? Could be a bunch of stuff. It's annoying. Normally, it'll let you see the machine, and again, I'd have to talk with CG Tech to find out why it's not displaying my machine in this view, because it should.
Right.
Because here, you know, I've got it set to machine. So if I go to add a view, there's my machine view. If I open up my machine components, you go to visibility, go to both views. Visibility, both views. Do a reset. Huh. It's just not showing me the whole thing, even though it should.
I'm curious, without the machine being visible, would it be able to interpret crashes with maybe the portion of the spindle, since it's just showing the tool now with the spindle collision checking?
It should, because even if all I have is my stock view, one of the great things about Vericut is even in the background, as long as you've got these components defined, it should show you those collisions. And got the door, we got the enclosure, there's all the tool change stuff, there's X, Y, Z. Let's see if I can find B and C. MC, B, and C. So if I go to models, I mean, visible is on, appearance, edge angle, all that stuff is on. Yeah, I mean, normally this stuff, at least in the machine view, would be visible.
Right.
We don't have no animation turned on, resolution is on.
It's very odd because I remember last time being able to see the machine during.
Oh yeah, like if I just open up Vericut, so if I save this, save it, yeah, I want to replace it. Ignore all changes. See, it's even being weird about me closing it. Okay, come on. Yeah, because this is what it should be. This is a machine cut stock view. It shows you the whole thing. You know, you can go and turn off stuff. So, like the enclosure should be able to make that visibility invisible. Should be able to go to like the ATC doors. Make that invisible. And yeah, it should show you the whole thing. And obviously they have some mistakes in this because that's the whole point. They want to show you, hey, if you've got errors in your part file, look, Vericut will catch it. Right? Look, we're slamming into the vise. We're doing all this stuff. And it looks like we got multiple setups in here. So it's basically, now one of the things that I can do, I'm going to reset. If I right click on the play button, I get options. Start at, I can tell it start at the beginning. I can tell it start at a certain line number, basically scroll through the entire program and simulate invisibly or without animation up to that point. Or I can just say, you know what, start exactly at this line number. Don't pre-simulate any of this other stuff. I can tell it to start at certain text or start at a certain tool ID. We're going to say start at the beginning. Stop at. I can turn on max errors. Hey, if I get an error, stop. If I get a warning, stop. Or I can tell it I want to stop at the end of each setup. I can do end of each file, end of each setup, when a variable changes, when a variable is set, when I hit a program stop, when I hit an optional stop, when a certain number of lines have been run, or if there's an annotated image. So I'll say stop at the end of each setup, or stop if we hit an error. So now when I hit play, uh-oh. Now, I didn't have an actual collision. It tells me, first of all, it tells me there's an error. I can't open the machine simulation log file debug.log, so that's a problem. But then it says, reset model complete, toolpath rewind performed, error, tool cutter exceeded near miss tolerance of 90 thou, basically just under 100 thou with the C-axis at this line. Now, it didn't hit, it just got close. But I have a near miss tolerance. If I go to collision, there's this little collision button over here. So I can say check collisions between stock and active tools holders, fixture and the active tools holder, fixture and the active tools cutter, fixture and the active tools shank, collision distance allowed between shank and stock, 50 thou, detect shank plunge error, tolerance 2 thou. I can even do a constant gouge or excess check. So basically I can say, hey, if I've gouged into the part by more than this amount, throw an error. And when I say gouged into the part, I'm not talking into the stock, I'm talking into the design model. Right? Because if we go to view and I go to stock and design, right, I've got stock loaded, but then I've got my design model. This is what I don't want to gouge in. So I could say, you know what, if I gouge in more than 4/10 or 2/10 or whatever that is, give me an error. What else do I have? If I go to machine and control, no, if I go to there's an option in here. Advanced app settings, no. There's an option in here for my near miss. I can even go in here and do MDI. I can drive the tool around. I can do all kinds of cool stuff with this. Vericut's a great tool.
What does Vericut consider as setup on the stop conditions sort of thing? Is that just like a plane change, or what's the setup?
So in the setup here.
No, earlier when you were selected on when it would stop, right? And you chose collisions or gouges, and then one was setups as well. Like, what is considered a setup? Is that just a plane?
No, that's literally if I am flipping stock between operations. So here I've got multiple setups. I've got setup number 1 and setup number 2. And so what's going to happen, I have 2 coordinate systems. If I reset this and I do display axes, where is it? Here's my view. Oh, is it because I don't have a stock view? It's probably because I don't have a stock view. So I'm going to go to view. I'm going to go to add a view. This gives me my stock view. And now display active work offset. Active coordinate system. Where's my visibility? Oh, I just found it here. They're always moving stuff around, right? Oh, visibility here is turned off. Display. There it is. Program 0, display. So there's my actual coordinate system, which is my active coordinate system, or my program 0, and it's located at some datums on the part, right? Then I have what's called a cut stock transition. And a cut stock transition is used to transfer cut stock from one setup to another. So in this case, I've got 2 setups. I've got setup 1 and I've got setup 2. It's the same machine, Makino D200Z with the FANUC 30IM. And basically, it's going to get all the way down to the end of this setup because I told it to stop at the end of the setup. Otherwise, if I said, stop at the end of the file, it's literally going to cut all the way. So let's just do that. So actually, I'm going to have it stop at the end of each setup just so you can see it. So let's have it stop at the end of each setup, and you notice in setup number 1, I've got the sheet metal all hidden. Okay? So we're going to play it, and I'm going to turn off stop at the errors, because I just want it to go ahead and play through. So it's going to play all the way to the end of the setup. So I'm doing all my cuts, I've got some errors, some gouges, some crap, and I'd obviously want to fix that, but I'm basically got down, and if we look in our stock model, there we go. So if we look in our stock model, what you can see here is we started with Vericut setup 1 stock STL or STK, stock model. What we have now is a cut stock and a tool and stock collision. So it actually has a separate model that keeps track of all of the collisions. That way, if you had a collision with tool number 1 and you breeze past and you cut that material away, tool number 2 could come along and you could miss the red. You know what I'm saying? You could miss that you had a collision unless Vericut keeps track. So it keeps track of all that stuff. So here's an actual collision. Here's an allowable gouge 4/10 violation. I could go back in here to collision and I could turn off my constant gouge check. I can reset, clear everything out, and I can play it, and I'm not going to get those maximum gouge allowance errors. So there's like literally so much you can do with this program. It's pretty damn sweet. But just to show you, here we have a cut stock model. It is in the first setup. Now, if I scroll down to setup number 2, you notice that stock component is empty. What I'm going to do is single step. It shows it's busy. And what it's doing is it's actually transferring that stock. Now, it usually doesn't take this long. It may just be a combination of weird stuff that I've pressed. It may be that, you know, something's weird in this particular version of Vericut, or it may be something weird with my license. But what it's really actually doing right now is should be transferring the stock from setup 1 to setup 2. And then, you know, the stock's going to be loaded on a different fixture, or it's going to be flipped around in the vise, or, you know, you can literally set up multiple what they call setups where you're taking the part from cradle to grave, all the way from the very start of the process, all the way through the end of your program, M30, and now you're going to take that part and you're going to move it to another vise, or you're going to move it to a different fixture, or you're just going to flip it over and set a new work offset. Whatever that process is, you can simulate all of those steps in Vericut inside one file by having multiple Vericut setups.
And that's even different machines as well, right?
Correct, 100%. So you could start out and turn a part on a lathe and put in all the turn features, and then you could take that part and you could load it in a fixture on your 5-axis mill, and you could simulate all the 5-axis cuts, and then, you know, or you could, you know, rough a part out to where you've got 100,000s of stock all over. Now you're going to take it out and heat treat it. Now it's not going to show you the heat treat, but you know, now you're taking your part back from heat treat and you're loading it in a different mill on a different fixture, and you're doing all of side 1, or, you know, op 10 or whatever it is, and then you're going to take that part out and you're going to remove it from the fixture, and you're going to load it on a different machine or in a different setup and in a, you know, different fixture, different vise, whatever, and continue the machining process until you're all done.
Are there any like some tutorial books and things as well that CG Tech sells for this stuff?
Most of the stuff comes with the software. So okay. I am going to do end task and just restart it, because that seems to be the best way at the moment. We'll just launch 9.2. 9.2 and 9.3 are essentially the same. All the Vericut 9 versions are essentially the same. There's little tweaks or differences, but not much as far as the interface is concerned. So here we go. When I launch this splash screen, or I guess what they call, I forget what they call it in here. If I go to view, welcome. So if I go to help, welcome, this is the welcome screen. Here's all the training. So verification milling, verification turning, verification mill turn, This is like literally all built into the software. Machine and control, optimization. So it's got help files on all this stuff. So if I click on help session M1M, it launches the PDF of that help session for me. So you start right at the beginning with the 1M, Introduction to a Vericut Simulation. So it takes you through quick access toolbar. These are the ribbon tabs. This is the ribbon bar area. Here's the view cube, graphics area, status lights, progress bar, simulation controls, message area, animation slider, project tree, configuration menu. And as you go through, and it basically just walks you through step by step. You know, here's the configuration stuff, review the project tree settings. And it's just got all this great info. I mean, this is how I learned Vericut. And if you go to their class, they literally take you through this shit step by step. So, I mean, yeah, you've got a guided tour and somebody to ask questions who can help you, you know, but if you're the kind of person that can read a pretty good tutorial and learn on your own, it's a pretty good tutorial. Now, remember, I tried to launch this stuff with 9.3 and it was not working. But I launched it with 9.21 and it comes up just fine.
Yeah.
So, you know, I could literally take this guy, you know, it's easier with 2 screens, which I'm sure you'll have depending on where you're working or whatever. But
I haven't had to work with one monitor in like
I know,
years,
right?
so.
I know. We're all spoiled, you know.
Yeah.
But it's a good thing. So let's do that. Let's go to 100%. There we go. So however you want to, you know, organize it, review the project tree settings. So it talks about all the stuff that's in the project tree. So the setup, the CNC machine, which has got the control and the machine components. By default, all the machine components are hidden because really, when you're running Vericut, you're not doing a lot of machine configuration. You're concerned about, let me expand all this out. You're concerned about a couple of things. You're concerned that your design model is there. So if I go to view, design stock, so this is like a casting, right? So it's got my stock model of the actual casting stock, and then it's got the design model of my finished part. And so there's material that I want to remove, but there's features that I want to leave behind and not wipe out. And so I've got an attached component, and the attached component is where I load fixtures, stock, and design. These are really the only thing you care about. And in Mastercam, same thing, stock, design, fixture, if I go to translucency, right? So that's what we're setting up. Stock, design, fixture, coordinate systems, which are handled by planes, and G-code, which is I'm going to take my tool paths and I'm going to simulate them. Or sorry, I'm going to post-process them. And in Vericut, unless you get into building machines and controls, which is fascinating, I've been doing it for, you know, since 2007 is when I started. I think I was on version 7 of Vericut. And I got into doing that for Boeing, and it was amazing. You know, it's changed my life. There's a lot of things along the way, skills that I've picked up for using different types of software that have really, you know, taken me into the top level of what a programmer can do. I'm not the best toolpath guy, right? There's a ton of people out there that machine parts day in and day out. And that's what they do. They write toolpaths, they set it up, they run it on the machine, or they have somebody else set it up and run it on the machine, and they've literally programmed thousands of parts, right? I'm in the hundreds. Right. But a lot of what I do is really complex. And a lot of what I do is also configuration of the post processor and configuration of the simulation. And there's not a lot of guys that have all those skills that can walk into a shop and say, hey, I can set up Mastercam and program the parts. I can set up Mastercam post processors so that you're getting good G code. And if you have it or you want to invest in it, I can set up your simulation software as well, both Complete and Vericut. Although my preference is for a good Mastercam post processor in conjunction with Vericut, because Vericut is super, super powerful. So there's all kinds of stuff in here for things like, looking at your status window. So I can go and look at the status window, and you can configure this so that you've got, it's basically showing you all the errors. You can record the cutting conditions. You can verify so much stuff in here, man. You can go in and set up graphs. So, you can graph the chip thickness or how the feed per minute changes over time, the axial depth, the radial width, the contact area, the volume of metal removal, feed per revolution, feed per tooth, spindle speed. You can do all the force conditions. Vericut has a module called Force where you can actually purchase these coefficient files for a specific material. So if you're cutting 17.4 pH at a certain hardness, you can either ask them to do a study and develop one of those files, or if they've already got it, you can just purchase the file and you can record all that stuff in Vericut as it's cutting, and you can actually set limits. So you can say, hey, if my programming parameters exceed the force characteristics of this material, go ahead and modify my G-code. And it actually creates a separate modified G-code file, right? So like you run your standard program, it runs optimization in the background, and it builds an optimization file. And let's say, you've got this cut that's going through the material, and there's one area where it spikes the load or something like that. It'll actually break. So let's say you've got one line of G code. It goes from X1 to X10, right? And there's a section in there where it encounters a taller wall, and that taller wall is causing a spike in load on the cutter. It'll actually break that single line of G code into multiple lines of G code, each with its own feed rate.
Yeah, that's amazing.
Dude, Vericut is absolutely bonkers when it comes to the stuff you can do. If you start looking at the machine and control files, and you start looking at like the G-code processing window, so this is basically you set up all these events. So here at the start of processing, here's all the values that it's going to set. It's going to set a bunch of dynamic variables at the start of block processing, end of block processing. It's basically, you can have it do all these different events. But then when you get into word address, clicking too fast. So here, for each of the states, GO, G1, anytime it reads those, it's actually changing internal variables and then changing the macro that is running internally to tell Vericut what to do. So here's, cycles, here's all the different cycles that are configured, and you can go in and set all this stuff up. So if your machine has custom G codes or custom M codes, you can have it literally, if it sets a variable on the control, if it calls a subroutine, if it causes motion, whatever it does, you can have it show you all that stuff. You can build subroutines in here, or you can load subroutines. So like if you're running a master file, and that master file is calling subroutines for every tool or for different tool paths. You can load all that stuff in here. I mean, if you look at like the Siemens 840D in Vericut, they've done some amazing work for setting up the 840D, because literally when you call a cycle 800 on a Siemens, it's calling a subroutine, and they have all those subroutines built in. So like if you go to search library 840 star. Oh, so it's encrypted. Anytime you see X sub, and that's probably why we were seeing that with the Vericut files, is where xply means it's encrypted.
Right.
So there's a ton of stuff in here that's encrypted. So they're just like, yeah, we're not going to give you access to that. We're not going to let you peek behind that curtain, right? Not for free. But if we look at like the def file, so this def file, these are actual Siemens variable names that are internal to the control. So with Vericut, you have a bunch of supporting files that go with the machine. So if I go to the machine, maybe it's the control, machine settings. So this is where so machine settings is where those near miss tolerances come from. So you can set up, and with collision detection, you can set up different collision detection pairs. So if I hit add, I can choose from any of the machine components to any other machine component. So I can say, show me collision between the tool and the B axis of the machine. So if my tool gets close to there, and if I maybe I want to set a near miss of 1/4 inch. If my tool gets within 1/4 inch of my pallet, give me a warning. I can add another one, and I can say, hey, let's do the spindle, which is the actual spindle component, and I don't care about, it's never going to hit the base. It physically can't.
Right.
But if I go to B, hey, that might get close, and you know what? I want to be able to get within, actually, show me 1/4 inch, but let my tool get within 100 thou.
Yeah.
Right? And I can tell it I want to search this and all subcomponents. So rather than having a separate one for spindle and tool, I'm going to get rid of that, and I'm going to say from spindle and all subcomponents to B and all subcomponents. You notice I highlighted everything. But I have to be careful, because I also have to look at, do I ignore a collision between the cutter and the stock? Most of the time I do. Most of the time I want to say, I want to ignore a collision between the cutter and the stock on the active tool, because I want to be able to cut my material.
Right.
You know what I mean? I can have a default near miss. I can assign subroutines like a tool changer. You can build a tool chain in Vericut, which will have all of your, basically the entire chain, whether it's an actual chain or whether it's a carousel or what have you, and you can load it up with all the tools that are in your tool think about it like a tool library file, but basically all the tools that you're importing from Mastercam, you can load them up, and then you can simulate the tool change arm. Come in, grab your tool, swap it out for the next tool, do the actual tool change motion, put the tool back in, and it's especially useful on something like a Haas mill with an umbrella tool changer, because you can say, hey,
Right.
I want to do collision detection between all my tools. Hey, give me collision detection between all my tools, because I want to know if anything in my carousel is hitting my part as my table's moving underneath it. Maybe I got a long reamer or something stupid like that. It's just hanging out there.
Right.
So it's not my spindle, but it's in the work envelope.
Would it also pick up on like big diameter tools,
Oh, yeah.
like large saws and stuff?
Yeah.
And, how they place them in the order? next to
Yes.
other tools?
Yes. I mean, you would build that down in the actual, so if I like turn on the machine components, this model is not built with a tool chain. But if I go to like the welcome screen and we grab Vericut init or vericut.vc project, so this guy has got like everything. And if I turn on all this stuff, expand all children, laser tool setter, so I can do collision detection if I'm doing like, a tool measurement macro, right? And I've got a face mill and I accidentally plunge it in my, $12,000 laser. That'd be kind of cool to be able to detect that, right? So yeah, you can
Right.
do that stuff. This one, I think, Aroa. I mean, this one's actually got a palette changer, if I'm not mistaken here. So it can actually change out, the palette and show that whole motion, which is kind of cool. I don't see a tool chain in here. So this is all for APC, automatic palette changer, right? I don't see anything for ATC. All I got is ATC door and then the tool change door. So they've simulated the tool change door. So like I can go, for
Right.
example, into my project MDI, and this should give me all the different. Oh, see, I've got multiple subsystems. So in subsystem one, which is the machine, I get XYZ So if I go to B and I rotate B, you know what I mean? You can see all that stuff move around, and you can build the kinematic chain for exactly how this stuff works. So if I go and grab C, oh, travel limit is set to ignore. So I actually have to go to the travel limits, go to my machine control, machine settings, travel limits, and I've got ignore set for C. So I'm going to turn that off, apply OK. I'm going to go back into was it project MDI, and now if I go to C, set this to 45, and then let's go to B, and let's set B. So I can rotate this thing all around, and we can build logic in here to do the automatic palette change, the automatic tool change, build a tool chain for the tool changer. In this case, they're saying, well, the tool motion for the tool change is going to go over here, door's going to slide open, this spindle's going to drop down, some robot or arm behind the scenes is going to swap out the tool, but it's not in the work envelope, so I don't have to worry about simulating it. But if I
Right.
go to my ATC, let's go 10. I can open the ATC door.
There it is.
You
Yep.
know what I mean?
Yep.
But somebody has to build that logic into it. I mean, I've done basically it was a 6-axis hole popper EDM that had a 2-axis rotary table. It had both Z for moving the spindle up and down with these little tiny EDM tubes, and a W axis, which was a support that slid up and down, and all kinds of crazy stuff. I mean, the one that I set up for, I won't name the name, but for that company down in Greenville, that was a pretty slick little system. I mean, literally, it showed the whole process of bringing the little pallet in. It would scan the part with the built up material. It would build all this stuff on the fly, and Vericut simulated all that stuff. One of the things I didn't
Wow.
mention in that conversation, and I'm not naming the name on the video, so I'm not too worried about it, was it would, create this stock model of the as-built stock for the part, and it would ship that all off to Vericut. It would launch Vericut silently. It would run the whole simulation, and that worked in about 95% of the cases, it was completely automated, and it just basically it scanned the part, it made the tool paths, it made the stock, it made the tool paths, it simulated it. As long as everything was good, it would actually just run the part. And in about 5% of the cases, it failed because there was actually some error. And if there was an error detected, it would actually kick that pallet out, and a physical live programmer would have to open up those files and look and find the error and figure out what they needed to do to correct it. And
That's nice. I mean, because they're only doing 5% of the workload that they could have had to do.
And it just ran 24/7.
Yeah.
So literally, you know, I didn't simulate the process of laying down the material with the cold spray, but that was all automated too. So literally, a guy would sit there on the shop floor and he would load up these little blanks. I won't mention what the part was for, but you know, he would load up these little blanks. It would cycle in with this little robot loader into the cold spray machine. The cold spray would build up material on the surface. I can say blade. It was a blade, so it would build up material on the surface of the blade. Once that process was done, the robot loader would take it and it would load it in the pallet station for the machine. And the pallet, I think it had like 80 pallets. And the machine, that way, at the end of the shift, at the end of the day, the guy could basically have, you know, 80 parts or whatever, 60 parts waiting to go. And the whole process of actually machining the blade took roughly 15, 20 minutes. So the scanning took, you know, the scanning and then building the stock model, the toolpaths in NX, the verification itself, and then the go, no go took about 8 minutes. So it would load the pallet in, it would scan the blade, the machine would sit there for 8 minutes while this process kicked off in the background. And as long as everything was copacetic, it would actually automatically load that NC file and it would machine the blade. The machining would take, you know, 15 or 20 minutes, depending on which blades they were running. And then it would kick it out and it would repeat all over. But, you know, you figure it took roughly a half an hour to do one. And so as long as there were no problems with the file, that whole process was running for like over 12 hours unattended. So that's 24 parts that they were, as long as there were no errors. And if there was an error, it wouldn't take more than about 8 or 10 minutes for it to be like, oh, there's an error, kick this part out. And it would just be like, okay, we're going to flag this pallet. We're going to pull it out of the system. We're going to load another pallet. We're going to scan it. We're going to build everything in the background. We're going to, you know, toolpath it, simulate it, verify it. Everything's good. Okay. Now we're going to run it. We're going to cut it. And so like literally the most they were losing is like maybe 20 minutes in an unattended shift. Dude, it was slick.
Well, I see we are getting a little late. I don't know how much further you wanted to continue tonight.
Yeah, man. I mean, if you want to go, you got to go to bed, get up early in the morning. No problem on my end.
Yeah, my girlfriend just got home, but you know, I figured you'd probably. I had a few other things just to mention, you know, but I'm glad we got to get through a lot more of the you know, kind of the lesson that I think you had planned today than last time, you know.
Yeah, this is a lot more practical of what I wanted to show you, where it's like, okay, we're going to run, you know, MCAMV, we're going to take a setup in Mastercam, or we're going to bring it in, and, you know, we're going to run it through. Unfortunately, there's something kind of still borked with my system a little bit, but at least I'm able to show you kind of on a on one of the sample files what's available in here. And, you know, we also talked about the help files, because the help files and the tutorials that they give you are extensive. You know?
Yeah, we had mentioned it a little bit last time, and you had compared them to, or maybe I made the comparison that, you know, SolidWorks has really good help files, and you're able to basically teach yourself the whole software with those help files
and this
tutorials.
This is very much, I would put it in that category. You know,
it's good testament to the creation of them if they're still teaching the classes from those
100%,
files.
100%. Because literally, when you go in to take milling verification from CG Tech, literally, this is what they take you through. They take you through all these sessions: introduction to a simulation, monitor a simulation file, find and detect errors, measure features with X caliper. There's a whole measurement thing that's built in here, so you can go and kind of query your cut stock or measure piece and do all kinds of crap. I mean, you know.
I thought that graphs was amazing too. I mean, the chip thickness,
Yes.
Graphing is like, wow, that's just so neat to see, because it's just something you don't see with your regular Verify and
100%.
Mastercam. You're like, okay, sure, I know what I programmed the OptiRough to be set at, but every now and then, everyone knows certain things happen that,
That's right.
even the OptiRough doesn't really, or Mastercam doesn't consider collisions.
Yes.
Like your back feed rates going over a chunk from your high feed mill at 300 inches a minute or 500, whatever. And then
those little scallops left on the floor from high feed mill operations. God, I wish CNC software would fix that. There's a whole bunch of stuff. You know what I mean? One of the things you'll notice, especially like if you're doing a dynamic mill on, say, I don't know, even like a half-inch end mill on a 4-inch internal circular bore, you're going to be overfeeding at the center. So if you program it at 200, so the very first little spiral out there really gives you a much higher chip load than once you start opening up that hole, the chip load starts to go backwards. I've actually been working on some code for a Mastercam post to detect that kind of condition and automatically adjust the feed rate downwards.
Oh, that's beautiful. Yeah, that'd be a badass post to have.
Yeah. Well, if you want to work on that at some point, do some testing with me. I'll give you the code for free.
Oh, wow. Yeah, I'd love to. I've, recently bringing in a lot of the higher end models for my tools, where the cutting edges on I use the 1.5 inch AXD Mitsubishi all the time. It's like one of my favorite tools, right, for roughing stuff. And for a while, I would just used to just make it a bull mill, put on the radius and call it good. Yeah. But then it was like, wow, it makes so much difference having that scallop in the center out, so you can actually see when you're leaving built up stuff in the center of the tool. And I think I even said on the forums once, I was like, man, it'd be nice almost in a way to have a collision or a no cut zone in there too, to where when you do exceed it, it doesn't still consider that set screw is just blowing away material, and it's eventually
you can do that in Vericut.
The
nice. Tool modeling in here is freaking awesome. So definitely something for another session. But like the actual tooling stuff is much more extensive than what Mastercam will do as far as cut and no cut and the plunging that you can do and stuff like that. So this one's actually got a force file that's attached to it. So this has got all the coefficients in the background, and you can tell it with the max ramp. So if you're exceeding a max ramp angle, it'll warn you. You can have it. You can have it give you errors for all kinds of crap, man. I mean, it's just like I said, it's extensive. So when it comes to building high feed mills and getting the perfect profile, you can bring in all those models and you can really set it up and really tweak it in to give you like the most realistic configuration and setup possible. So when it comes to measuring all the forces and doing all that stuff, I mean, it's engineering that goes way beyond what you can do with CAM software alone. Like it's really Vericut is really the perfect complement to a good CAM software package.
Yeah, if you were ever going to be an offline programmer, I would see this as like absolutely vital, because I've got luckily you were saying earlier how, you program hundreds of parts or whatever, not maybe quite the thousands that some other, but I definitely am in that thousands of category of, and it's cool that, and I used to run a lot of my own pieces obviously too. And, I got a good reputation with some of the guys, almost too good. I might have mentioned towards sometimes they just hit that button, they walk away, they act like it's a proven program. And it's like, dude, that's the first time I posted it. I don't run Vericut and I don't even have my post-driven simulation anymore. So it scares me sometimes when these guys are just hit and go on my programs and like, oh, no, you're fine. You've never done us wrong. And it's like, yeah, but the one time I do, it's going to be really expensive if you're not out here.
100%.
So. But yeah, no, I just had one other thing I was going to mention because I think, a person of your knowledge and I got a friend that runs a podcast. I don't know if I mentioned this before. He's actually pretty popular in the machining world on the podcast scene. It's called Within Tolerance.
Okay.
Yeah, he's my friend Dylan Jackson. He runs a shop called Prodium. They featured him on Practical Machinist, doing some tours on YouTube and stuff. But I thought, it'd just be something to, maybe listen to him a few times, maybe be interested in chatting with him. His is a much shorter show. It's usually 30 minutes to hour-long episodes, right? I've been impressed. I mean, he's gotten some pretty big, like, tool manufacturers, guys from just all over the industry. I'm really super proud of this guy. I went through the community college with him, and I actually used to do the music for his motorcycle videos back when we were 10 years younger.
Cool.
So
no, I love
just
to
thought
talk.
I'd pass that
I'd
along.
love to talk with him. Absolutely. It's manufacturing is a small industry, right? CNC machining is just an even smaller subset of guys that are into manufacturing. And the reality is that the methods by which we are learning and training, the younger generations are changing. And so, things like podcasts, anybody who's got a following. I mean, my following is pretty small, but I'm always shocked at, the people that I run into who's like, oh, you're that Mastercam guy, or you're that post-processor guy, blah, blah, blah. Like, I've seen your videos on YouTube, and I'm like, well, that's weird, man, because I have like 750 subscribers, so maybe you watch all my videos, but you don't subscribe. So give me a like and a thumbs up.
I remember when I found your videos, I was like, this is exactly what I've been looking for. It was just such a cool moment to find them.
Cool.
I haven't utilized them enough lately because, as you know, they work me to death where I'm at right now.
Well, sometimes you can learn so much from watching a video, but sometimes you have to have time to get in and jump in and play, and it can be hard.
Right.
It can be hard when you don't have somebody walking you through it, especially if it's something wildly different, right? Like programming, like doing this is more akin to programming than post-processing, because post-processing is all software, right? So when I started learning about softwares, I'm like, variables, strings, what the hell is this, and I'm fumbling my way through it at the very beginning. But then you take a training class, or you watch my videos or whatever, and it's like, okay, I can see where he's going in there and he's changing this, and I can see the change in the output of the NC code. Okay, cool. Now at least I have some semblance of a starting point of where to go, and then it's all about finding the time and being able to play around and try the stuff yourself. But one of the things I'm getting ready to do, like I don't know if I mentioned it, my wife's got multiple sclerosis, so I'm going to put together. I was trying to think of, well, how can I raise money to have? So she needs a stem cell transplant. Like, that's where we're at. Like, all the medicines she's on, she's tried like 14 different things over the 19 years she's had this disease. And even her doctor is basically like, well, I can't recommend legally that you go get a stem cell transplant, but I just had a patient who went down to Mexico and had this done, and I can tell you that they're doing really great, and there's really no more options for you, So, yeah, so what I'm...
At least there's still an option. There's still something to go.
Yeah, and this is it. This is the kind of the last ditch attempt, but they've got an over 80% success rate in at least halting disease progression, and in many cases, it actually reverses a lot of the symptoms. So I'm just like, wow. But it's also $55,000. So I'm like, oh shit, now what do I do? So so I'm actually going to do basically I am going to start doing training classes again, but instead of charging for them, because that would be kind of a conflict of interest with my work, I am going to be doing them online for free, but then doing small plugs for donations for her GoFundMe to help, see if I can help fund her month stay down in Mexico. And the thing that sucks is they've approved stem cell transplants for things like cancers. but not for multiple sclerosis in the United States. They've done a bunch of trials. You know, they've done a bunch of that stuff, but not. Basically, the foremost guy in the world for doing it is down in Puebla, Mexico, Mexico, and it's not cheap, but it's worth a shot, man.
Yeah, definitely. I mean, and I'll definitely be watching out for that, and you know, you can definitely count me in for some of that.
I appreciate it, man.
For sure.
Cool.
And the you know, I think he does have a pretty good following on there, so yeah, I think that would be perfect. You know, it might be cool to get on that podcast.
Yeah, I'd love it.
Help put that out there.
Yeah,
too.
love to you know, and the primary reason for it for me is just to help other young people in the industry, you know, learn to do their jobs better and change their lives, man. I mean, it's the same reason I'm jumping on with you is because I know you're, you know, looking at this new position, and man, I hope you get it.
Yeah, I mean, yeah, like I said, it's this Thursday is my team's interview, so you know, I took the day off for that, so I'll be home and ready. And then they've already mentioned getting me out there, so I can't wait to do the in-person too. And I've definitely checked out a lot of places and read a lot of articles on where to live, and you know, I'm hoping it all goes through. So
Select, man.
I thank you again as
For
always.
sure.
And yeah, try to get some sleep. I know it's later there for you than it is for me, but
Yeah,
hopefully you don't get up as early as me.
not super early, but my cat wakes me up at like freaking between 5 and 6 every morning. I have a built-in alarm clock, so I heard your.
Yeah, mine kept coming in the damn room too. I don't know if you heard him in the background a few times.
Yeah, yeah, you gotta love him, man.
Well, anyways, thanks
All
again,
right.
Colin.
You're welcome,
Yep.
Joseph. Have a great
Talk
night,
to you
man.
later.
I'll see you.
Bye.
Bye.
You too.